Agentic security is powerful when autonomy is paired with control. In this topic, we'll examine the patterns that make AI agents useful, observable, and bounded, and the anti-patterns that lead to overreach, blind spots, data leaks, or lost trust. So far, we've looked at what agentic AI means for security, where agents fit across SOC, IR, hunting, and posture work, and how enterprise and multi-agent architectures are organized. Now we shift to secure design patterns, how to make these systems safe, resilient, and ready for production. When an agent can query CM data, open tickets, change IAM settings, or trigger SOAR playbooks, it is no longer just an assistant. It is operational software with privileges. Secure design starts with 3 questions. What could go wrong? What impact would it have? And what control prevents it? Limit permissions, refresh context, require approval for risky actions, and log decisions. The goal is constrained autonomy, useful speed without open-ended authority. Least privilege changes the design question from what can this agent do to what must it do right now. Begin with task-specific roles. Read, recommend, stage, and execute should be separate. Then bound access by time, using just-in-time approval for risky actions such as isolating a host or suspending an identity. Finally, limit scope by environment, asset class, business unit, severity, or assigned case. The smaller the permission envelope, the safer the agent. A reliable agent should not receive the whole enterprise universe. It should receive only the smallest useful context for the case. Raw telemetry first passes through policy controls that remove PII secrets and unrelated privileged data. Retrieval ranks sources by relevance, and summarization compresses evidence into labeled case-specific facts. Just as important, every fact keeps provenance. That gives the agent less noise, fewer unsafe paths, and outputs analysts can trace back to evidence. Security tools should not be exposed to an agent as open-ended APIs. Put a secure interface in between. The agent requests an action, while the wrapper limits commands, checks identity and policy, validates scope, and can require approval or a dry run first. For risky actions, such as isolating an endpoint or disabling an account, the tool should return structured evidence, errors, and rollback information. This turns automation from raw power into governed, auditable execution. One practical governance pattern is to separate actions by operational impact. Tier 0 is observation and analysis, where autonomy is usually safe. Tier 1 covers reversible response support, such as tickets or notifications. Tier 2 introduces staged change and approval gates. Tier 3 affects production, identity, or containment, so it requires human authorization, logging, and rollback plans. The aim is not less automation. It is the right automation for the right level of risk. Approval patterns help agents move quickly without taking ownership away from people. The agent can detect an issue and recommend an action, but risk determines the next step. If the action touches access, production, compliance, or another high-impact area, it pauses for human review. The approver should see the evidence, expected impact, rollback plan, and safer alternatives. Once approved or rejected, the decision is logged, keeping execution and accountability traceable. Before an agent changes production, give it a safe place to be wrong. A firewall rule, IAM policy, EDR isolation, or cloud fix should first run in staging, a sandbox, or a digital twin. Simulation estimates who and what will be affected, then compares expected results with observed behavior. Only when outcomes match should the action escalate. Keep test and production credentials, tools, and permissions separate, so validation cannot accidentally become real impact. Canaries give agent-driven changes a small, safe proving ground before they reach the wider enterprise. Start with low-criticality assets, test accounts, or a representative user group. Then watch agreed metrics, failed logins, endpoint health, alert volume, latency, and support tickets. If results stay healthy, expand gradually. If thresholds are crossed, stop automatically, and trigger a tested rollback or compensation path that restores the known good state. The failure mode is not that the agent is powerful. It is that the power is unbounded. If an agent can change IAM, cloud, endpoint, and network controls without approval, one bad recommendation, Prompt injection or flawed playbook can become an outage. Treat production permissions like hazardous tools. Tier actions by risk, require approval for disruptive steps, scope credentials tightly, and make rollback part of the control design. An agent should not be treated like a universal inbox. If raw logs, emails, vulnerability reports, secrets, and HR records all flow into the same prompt, the model gains more exposure than insight. Irrelevant data can confuse reasoning, and hostile content can become a prompt injection path. The safer pattern is scoped context. Include only case-relevant evidence, redact sensitive fields, separate tenants and incidents, and score sources before retrieval. Silent failure is especially dangerous because it preserves the appearance of control. If an API times out, a policy blocks an action, evidence conflicts, or confidence drops, the analyst must know. Log reasoning summaries, tool calls, approvals, denials, and final outcomes in a form people can review. Then monitor drift over time, quality, policy adherence, false positives, and missed detections. When uncertainty appears, the safe behavior is not to improvise. Escalate, pause, clarify, or revert. At this point, the goal is repeatability. A pattern catalog turns individual agent designs into reusable security playbooks. Account takeover needs identity context, approval gates, staged revocation, and rollback. Lateral movement needs enrichment, graph correlation, escalation, and tightly limited containment. Misconfiguration fixes need dry runs, staging, canaries, and change control. Threat hunting is different. It should retrieve evidence and track hypotheses, but avoid production changes. Patterns let teams move faster while keeping risk controls consistent. Trusted agents are designed, not assumed. Constrain them with least privilege, scoped context, safe tools, and tiered actions. Validate changes through approvals, staging, canaries, and rollback. Avoid over-autonomy, unbounded context, and silent failure. Next, we'll turn these patterns into operational workflows for security teams.